we are done, I'm going to forward it to you via inbox so that you can catch up at a later stage. Né?
Okay, sir.
Okay, so what I was saying is I'm not preparing you for your classwork, homework, assignments, project, whatever. I want you to pass with good marks at the end of the year. And now that we have started, in case if you do enjoy my lessons and you understand my teaching style, then I'll be preparing you for your matric. So some of the information you will discover as we continue. But for now, just be aware that I'm going to be starting you from the beginning. So let's see. Trigonometry. Okay, so Jasmine, when we are talking about trigonometry, we are simply studying the relationship between sides and angles. It's as easy as that. I'll write this one, Jasmine. We actually study let me just adjust my lighting. I think it's now clear. We study the relationship between sides and angles. So this is what you need to be aware of, Jasmine. Every time when you start a chapter or when you're studying something new, ask yourself exactly what are you dealing with. In that way, you will have a better understanding as we continue. You might know there's something that is called a triangle, but you are not aware in terms of exactly what we are dealing with. So can you see in my statement there, I'm saying in trigonometry, we study the relationship between sides and angles. And most importantly, we are dealing with a right angled triangle. So that word trigonometry, it actually has this that I'm talking about. So you might find that metry, it refers to the study, and then trig, it refers to a triangle or something like that. So we are simply saying in trigonometry, we study the sides and angles. So I'm going to draw something here, Jasmine, and I will need you to unmute your mic. I'm going to help you to answer this question. Jasmine, which shape or what is the name of shape number 1? What is the name of shape number 2?
The left number 1 is a right angle triangle, and number 2 is a triangle.
Jasmine, how do you see that number 1 is a right angled triangle?
Well, so you can see that it has a 90-degree angle in the shape itself.
Okay, so Jasmine, that is a common mistake that every learner do. So this is not a right angled triangle, Jasmine. The reason to that is because there is no one who said it's a right angled triangle. And again, I understand you are looking at that angle there. Can you see? It looks like it's a 90-degree angle, but it is not. It's only a 90-degree angle when it has this thing, Jasmine. If it doesn't have that, but it looks like it's a 90-degree angle, it could be 89, that angle. It could be 89 degrees. Do you agree that if it's 89 degrees, therefore it means we are not having a 90-degree angle over there? Do you agree, Jasmine?
sir.
So that means, Jasmine, for you to say this is a right-angled triangle, firstly, you must see that sign. If it's not there, we don't say it's a right-angled triangle. We just say we are not sure, or we are not told if it's a right-angled triangle. And secondly, for you to notice that it's a right-angled triangle, if they draw something similar to that, and then from there, in the statement, they say maybe triangle A, B, and C is a right-angled triangle, even though they did not draw that shape over there, but because they told us, then it is a right-angled triangle. Here comes a question, Jasmine. So I'm going to draw that. I'm also going to draw that. Tell me, triangle number 1 and triangle number 2, what are those?
So they are not right angle triangles for sure.
Why?
Because they don't have the little square in them, and they don't nobody specified like if they are a right angle triangle.
100%. I'm now becoming happy, Jasmine. So exactly what you said. These are not right-angled triangle. So you just say they are triangles. So this is just a triangle. This is just a triangle. Is it a right-angle triangle? No. Why? Because we are not told, number one, and again, we do not see that a 90-degree angle sign over there. So Jasmine, in trigonometry, we are only dealing with a right-angled triangle. We are not dealing with just any triangle, but we are dealing with a right-angled triangle. So that means always in trigonometry, we are focusing on right-angled triangle. So let's say there we've got A, B, and C. So next time, Jasmine, this is how you're going to interpret a right-angled triangle when I ask you. So you're going to say, what you are seeing there is a triangle, number one. Number two, it is a right-angled triangle. Why? It is because we see that whatever square or that sign over there. Otherwise, you can say, if we did not have that, we might be told that it's a right-angled triangle. So now that this is a right-angled triangle, how many sides do we have, Jasmine?
3.
How many angles do we have?
3.
So can you see that in trigonometry, we are simply studying the relationship between 3 sides and 3 angles. Can you see? So here comes a question, Jasmine. What angle do you know its value there?
The angle of B,
What is it?
it's 90 degrees.
What about angle of A?
Well, we know it's less than 90 degrees.
Angle of C?
Less than 90 degrees.
100%. So now let's talk about the sides. So let's say this is side number 1, this is side number 2, this is side number 3. So do you know, Jasmine, that in trigonometry, each side has got a specific name? Do you know?
I think so.
Give it a try.
Um,
What names are we having in a right-angled triangle?
Is it hypotenuse, opposite, and adjacent?
100%. So that means in a right-angled triangle, we've got what we call hypotenuse, we've got what we call a opposite, we've got what we call adjacent. adjacent. So that means in a right-angled triangle, we've got three sides, namely hypotenuse, opposite, and adjacent. And again, we still have three angles. So that means we're going to have angle number 1, angle number 2, and then the other angle number 3. Let's say we know it is always 90 degrees. So this one we don't know, but we know it's less than 90 degrees. Also that one we don't know, but we do know that it is also less than 90 degrees. Most importantly, Jasmine, we know that the sum of all of these angles, it's going to be equals to 180 degrees. I'm sure this one you know very well, that the sum of interior angles of a triangle are equals to 180 degrees. So here comes the question, Jasmine. Which side between number 1, number 2, and number 3 is which side? Can you try and label those sides?
Number 2 is the hypotenuse.
Mm-hmm.
Wouldn't the opposite be number 1, and then the adjacent will be number 3?
Okay, a very nice response over there, Jasmine. I'm going to tell you something. There's a reason why you took a pause after you've correctly said number 2 is hypotenuse. But before I even do that, how do you notice that number 2 is hypotenuse?
Because it's opposite the 90-degree angle.
100%. So it is opposite to 90-degree angle over there. So I'm going to tell you the reason why you took a pause, Jasmine. The reason to that is because you don't have an angle that you can use as a reference in order to give the sides other names. So
yes, sir.
That means you can never know if number 1 is adjacent or opposite. You can never know if number 3 is adjacent or opposite, only if you do not know where is the reference angle. I'm telling you, Jasmine, based on what we have done up to this point, on our very first lesson, I'm able to notice that you've got an idea. You are a rough diamond that needs to be worked out. I'm telling you, this is what I'm going to do, and you are now going to get it correctly. So if we've got an angle over there, which side is adjacent and which side is opposite?
Opposite would be number 3, and then the adjacent would be number 1.
100%. So do you know what does it mean, Jasmine? It means you can never tell which side is which if you do not know the reference angle and again the 90-degree angle. So that means you need two of these things in order to tell which side is hypotenuse, which side is opposite, which side is adjacent. Does it make sense, Jasmine?
Yes, sir.
So do you now have the confidence in terms of answering or analyzing a given right-angled triangle? Are you now confident?
Yes, sir.
So that's what I meant, Jasmine, when I said everything should make sense. It shouldn't be that in class you were just told that this is a right-angled triangle, this is adjacent, this is whatever. So you need to think beyond what the teacher teaches you in class. I notice that you will understand more of my upcoming lessons, Jasmine, on trigonometry. So what I'll be doing is to make sure that you've got the confidence. So in short, what we've discussed, Jasmine, is that in trigonometry, we study the relationship between 3 sides and 3 angles. So we are only dealing with a right-angled triangle. How do you notice a right-angled? That's when it has that 90-degree angle over there. And most importantly, since we say it has 3 sides, it's 1, 2, 3. Which side is which? Only if I know my 90-degree angle is there, Then opposite to that, it is my hypotenuse. So only if I know where the reference angle is, I can be able to tell which side is adjacent and which side is opposite. So that means in a right angled triangle, we've got three sides, namely hypotenuse, opposite, and adjacent. So we also have three angles. What are those three angles? We've got one over there, as you said, less than 90 degrees. We've got angle number 2 over there, also less than 90 degrees. And we also have the third angle being 90 degree over there. And most importantly, the sum of these three interior angles will be equals to 180 degrees. Happy there, Jasmine?
Yes, sir.
100%. So now I want to talk about, remember, you don't need to worry about having to write all of this, Jasmine. So I'm having this lesson recorded, so you can catch up at a later stage. So everything that I'm writing here, don't worry that. Okay, so I want to talk about what we call a Cartesian plane. Jasmine, in short, do you want to guess what is a Cartesian plane?
It's a graph.
What
It has
type
an
of a graph?
X, Y axis.
Continue, Jasmine. Let me know when you're done.
I think that's it.
Okay, no, it's fine. You are in the right direction. It's more like you know what is a car, but you're not able to describe what is a car. So this is a Cartesian plane. A Cartesian plane, Jasmine, you don't really need to say it's a graph. You can just say it's a vertical line and also a horizontal line, and we call these lines axes. So that means a Cartesian plane, it is made of an x axis and again a y axis. This is what we call a Cartesian plane, and most importantly, it has this point of intersection of the x-axis and the y-axis, and we call this the origin. So that is why they normally write O over there. So that O, you can regard it as origin or O for origin or O for zero, because there it's zero. And then from there, in that direction, we've got positive x values. From the origin in that direction, we've got what is it? Negative x values. From the origin going up, we've got positive y values. From there going down, we've got negative y values. Jasmine, this is what we call a Cartesian plane. Are you happy there with that explanation?
Yes, sir.
So, Jasmine, we draw functions or graphs on a Cartesian plane. So, do you now understand why I said in future you can just not say a Cartesian plane is a graph? Does it make sense?
Yes, so it makes sense.
Yeah, so it's more like a Cartesian plane. It's your nice plate over there. So on a plate, that's when you can put in some food there, a chicken over there. So you don't say this thing is food, but this one is a plate, and then this one is a graph. It could be a straight line graph being your meat, and then you've got your what is it, spaghetti there, which is another graph of parabola, and then you've got whatever there. What is it? It could be gravy, then it's a graph of hyperbola, and then again, what else can we be having in your plate over there? I know you like eggs, Jasmine. So this is an egg over there. This is an exponential function. So can you see? This is a plate where we put in all the food inside the plate. So this is a Cartesian plane where we draw all these functions on a Cartesian plane. So now that you are able to distinguish what is a Cartesian plane, it will be easy for you to notice the functions drawn on a Cartesian plane. But in today's lesson, we are not talking about the functions. We are on trigonometry. So let's talk about anything that is to do with a trigonometry on a Cartesian. So Jasmine, we've got this line. It's just a line. Don't worry that much about it. So you know it as a hypotenuse, but it is normally called a terminal side. A terminal side. So it's more like I'm saying this is a car, and we've got a windscreen, we've got the wheels, we've got a steering wheel and everything. But with me telling you all of that, I'm not really teaching you how to drive. So when I start teaching you how to drive, I'm going to tell you. But for now, I'm just telling you that this is what we call a Cartesian plane. We've got that line of which I'm going to explain, and this line is called a terminal side. And then from there, we've got an angle forming from the x-axis in an anti-clockwise direction. So we call this an angle of inclination. So you can just say maybe what is it? Inclination angle over there. Okay, so Jasmine, normally we have our angle forming over there. So don't worry that much about what I'm saying, Jasmine. You just need to be aware of this information. At a later stage, it is going to make a perfect sense. So in terms of the angles, you remember we've got a 0-degree angle over there. So it's more like, Jasmine, you have this line like that. This is the terminal side. So as this line rotates about the origin, can you see it forms an angle? So that line is there. So can you see it forms a certain angle, and that angle, it starts from 0 because it was a horizontal line. The terminal side was on that x-axis. So if it rotates in an anti-clockwise direction, it forms a certain angle. And the moment it is vertically upwards, then it forms an angle which is a 90-degree angle. Why? Because you can see over there that it forms that shape of a 90-degree angle over there. And then now, Jasmine, as that same terminal side, as we continue to rotate it, can you see? It now heads towards 180-degree angle over there. Then it continues, Jasmine. It continues, and then it gets to 270 degrees over there. Then it continues and it continues and it continues up until it reaches 360-degree angle over there. So that means this terminal line, we just drew it like that, but it can be drawn in any direction. But whatever direction it is drawn, it has a different angle. It could be drawn like that. That means the angle formed is from the origin, from the x-axis all the way up until where that line is. Then we can refer maybe to that angle as beta. So otherwise, if you draw it in that quadrant, the angle, it is always formed from this 0 line, that 0 angle, and then it rotates in an anti-clockwise direction up to there. Again, if you draw it in that quadrant, doesn't matter. Maybe this one, let's call it a what angle? Okay, let's call it angle J for Jasmine. And then this one, it also starts from there up to Z. Then we can call that angle D for Desmond. So can you now see, Jasmine, that we have what we call terminal side, we have what we call an inclination angle. So that means this is an inclination angle, inclination angle, inclination angle, inclination angle. Did this make sense, Jasmine, what I've explained over there?
Yes, sir, it made sense.
100%. So now, how many quadrants do we have in a Cartesian plane?
4.
What do we call the first quadrant being that one?
Quadrant 1.
Okay, I'll give you an example. So this one, Jasmine, we call it acute angle. So that means all the angles which are less than 90 degrees, it means they fall in the first quadrant. And this quadrant, or those angles, we call them acute angles. So this is going to be your second quadrant, obviously. Do you remember what we call those angles there?
Obtuse angle.
100% obtuse angle. And then this one, reflex angle, isn't it?
Yes, sir. Reflex angle.
And then this one,
Revolution.
Revolution. Jasmine, I'm very much happy up to what we have done so far. So let me check. For now, this one, let me leave it there and then we continue. So I think what we have covered, let me not even erase this. Okay, I'm just not sure if I'm going to need that information, but I'll just bring another board over there and say, let me just quickly check on my notes. I think we've covered most of the things. Hypotenuse, opposites, those are the sides. You are able to identify. Okay, so Jasmine, a right angled triangle, it's not necessarily only drawn there. It can still be drawn on a Cartesian plane. So this is how we draw a right angled triangle on a Cartesian plane. And the angle formed is there, Jasmine. Also on this side, we have a 90-degree angle there, angle formed is there. Also, on the third quadrant, angle is there. This is the 90-degree angle over there. So, also there, the angle formed is that one over there. So, this is a Cartesian plane, x axis and y axis. So, for the triangle in the first quadrant, Jasmine, which side is the opposite and which side is the adjacent?
Which one, sir?
So on the first quadrant, on the triangle in the first quadrant, which side is opposite, which side is adjacent?
The side that's like closer to the x-axis, that would be the opposite, and then the side that's on the x-axis is the adjacent.
So you are saying this side is what?
Opposite.
100%. So now I'm going to help you to correctly interpret this. So we therefore say on a right angle triangle drawn on a Cartesian plane, we call it the y, which is a positive y, and we know this is the opposite side. We call it y because it is the vertical side, and then this one, it is positive x. Why positive x? Because on this side is the positive side, and we therefore call it the adjacent in brackets there, as you know. So for this one also, Jasmine, we have positive y being the opposite there. Then we have negative x being a adjacent side. Why negative, Jasmine? Can you tell me why is it negative x on this side?
So the values on the bottom is usually negative.
Not on the bottom, but on the left side of the x axis.
Yes, sir. Yes, sir.
100%. So here, what will be the y? Will it be positive or negative?
Negative.
100%. So that means opposite here is y, and then here, what are we having as y? Also is negative. We know is opposite. So Jasmine, in terms of the x values, it doesn't change. For this triangle and for that triangle, the x values are negative. So it's y which is positive on the quadrant in the second, and then the quadrant, I mean the triangle in the third quadrant, you have negative y. Also here, you have negative y, but the x are positive. First quadrant, positive y, positive x. So the hypotenuse, Jasmine, what do we call the hypotenuse? Can you guess what is called the hypotenuse?
I'm not sure.
Okay, so I'm going to help you to answer this one such that you will never forget. So you have a Cartesian plane, Jasmine. It's y and it's x over there. Do you agree, Jasmine, that for that 360 degree angle to be formed, that's if we have a circle. You remember that triangle, it does something like this, and then from there, that's just where we have 360 degree over there. So this is a circle, Jasmine. So from the center being the origin, let's say to the edge of that circle, what do we call this line, Jasmine? So this is a circle, but what do we call this line?
I'm not sure.
Okay. Again, I'm going to try possible ways, Jasmine, just so that you will never forget. If I tell you, it might be easy to forget, but if I make you to get it correctly, you will never forget it. So this is a circle, Jasmine, and this is the center of a circle. This line, it has a name, Jasmine, and this line, it has a name. I will tell you, this is the diameter. From there to there is the diameter. But from there, the center to there, what do we call that line, Jasmine?
The radius.
100%, which means on a Cartesian plane, we call this line R. In your mind, you know very well that R, it actually represents the hypotenuse, just like Y represents opposite, X adjacent. So that means this is going to be our hypotenuse because it's opposite to that. But in trigonometry, we call it R when we are dealing with a right angle triangle on a Cartesian plane. Also, this is R, this is R. Are you happy there, Jasmine?
Yes, sir.
Okay. Do you know the Theorem of Pythagoras? Or have you heard about it before, Jasmine?
Yes, sir.
So that formula, it is made of 3 letters. What are those letters, Jasmine?
A, B, and C. Well, it's a formula.
It's a formula made of 3 letters. So you're saying A, B, and C, isn't it? Jasmine?
Yes, sir.
Okay, so from now on, Jasmine, before you understand it as A, B, and C, let me explain to you exactly where that formula is coming from. Do you agree this line is R? I hope you do agree. This is a Cartesian plane, you can see. We are only focusing on the first quadrant. So can you see we've got a right angle, the triangle over there. So this is R, Jasmine. This side is X, and this side is Y. So 1, 2, 3, they form that formula called Theorem of Pythagoras. And that formula, it says R squared. They are talking about this R being the hypotenuse. They are saying this side, Jasmine, it's actually equals to this side squared. And plus it with this side squared. So this is where the formula is coming from, Jasmine. It's more like this length. It's actually the same as when you add this one and that one, and this squared is equals to that squared plus that squared. So now that you know where this formula comes from, so you can therefore use any letter. That is why you can say maybe, what did you say? If you said a squared is equals to b squared plus c squared, this is the representation of that formula. So this is where it comes from. And then now, based on what you are given on a triangle, you can just use those letters to rewrite the formula. For example, if they give you a right-angled triangle similar to that, and they call this side Jasmine, this one Desmond, this one, what is it, P. So that means if you want to apply the theorem of Pythagoras, you just need to know which side represents the radius. You know it is that one. So that is why you are going to say d squared is equals to adjacent or whatever opposite, adjacent or opposite. So it's p squared plus a j squared. Then you have formulated the theorem of Pythagoras based on the information that you are given over there. But originally, this is where the formula comes from. Does it make sense there, Jasmine, or am I losing you?
No, I understand.
Well explained name.
So,
Okay, so there is something, Jasmine. There is something called. Okay, no, I'll just use this whiteboard. I actually wanted to use that other one. I'll just see how far we can go. So there's something called trigonometric ratio. It can be shortened as trig ratio. Is there something that you know about a trigonometric ratio, Jasmine?
is that where a SOHCAHTOA comes in?
This is where SOHCAHTOA comes in. So the word ratio, Jasmine, it simply means something over something, or a something per something, or something is to something. This is what we call a ratio. For example, 2 over 4 is a ratio. 1 over 2 is a ratio. Or maybe you get a 45 out of 100. This is a ratio. When you say 1 is to 2, this is a ratio. So because we are dealing with trigonometry, Jasmine, and you said this is where SOHCAHTOA comes in. So that means in trigonometry, we've got 3 trig ratios. What are those? The first one is sine, the second one is cos, the third one is tan. These are what we call the trig ratios, Jasmine. So in terms of letters or in terms of weights, we know that sine, what is sine, Jasmine? Can you just tell me what is sine, what is cos?
Sine is opposite over hypotenuse, cos
Okay.
is adjacent over hypotenuse.
Tan,
Opposite over adjacent.
opposite over adjacent. Okay, 100%. So now that we've got all of those, let's see. In terms of x, y, and r, just remember that x represents adjacent, opposite, hypotenuse. So that means sine, Jasmine, a sine angle, it doesn't matter whatever the angle can be, theta, whatever, let's just use theta. A sine angle will be equals to what in terms of x, y, and r, Jasmine?
Well, so I don't really know if x, y, and r is hypotenuse, adjacent, or opposite.
Okay, let me draw that. So I wanted to draw it here so that you can nicely given answer. So this is the right angled triangle, and remember the angle formed is always there, Jasmine. So that means we have y, we have x over there. So you know very well that this is your r. So this side, what is it? Is it x or y, Jasmine?
The opposite would be y,
Mm-hmm.
and then the adjacent would be x.
Okay, so what will sine angle be in terms of x, y, and r?
Y over r.
And then cos,
X over r.
and then tan,
Y over x.
100%, 100%, Jasmine, 100%. Okay, so this is all that I wanted to talk about with regards to trig ratios. So always, Jasmine, in terms of y, x, and r, just know that they actually drew a right angle triangle in the first quadrant, and they know the angle formed is always there next to the origin. So that means already you know what is your adjacent side, what is your opposite side. And this side is your adjacent, and this side is your opposite. Obviously, that one over there, it becomes your r. So that r from that, what is it? That circle, Jasmine. You remember that circle that does something like that. This is the center, is the origin. So this is that r being radius or your hypotenuse. So there's something, Jasmine, there's something called reciprocals. Have you ever heard of the word reciprocals, Jasmine?
No, I have not.
You've never heard of those?
So,
Okay, so since we have three trig ratios, Jasmine, we also have three reciprocals. The reciprocals, it's more like the inverse. The word reciprocal, you can just regard it as the inverse for now. The inverse of the trig ratios. So the inverse, Jasmine, it simply means if you have P over Z, the inverse of this, you write this at the top and then you write this at the bottom. So that means the inverse is Z over P. If you have 2 over 4, the inverse of this is going to be 4 over, what is it? 2. Does it make sense there, Jasmine?
yes, sir.
Okay, so can you guess what will be the inverse of sine? Of sine angle?
Hypotenuse over opposite.
100%. So it's going to be hypotenuse over a, what is it? Over opposite. Yes, over opposite. So a, in terms of x, y, and r, what are you going to have there, Jasmine?
R over y.
R over y. So always, this is how you interpret them. You say sine, or maybe let's say sine is actually opposite over hypotenuse. And then in terms of this and that, you must also be able to, what is it? You must also be able to interpret it. But because this is not sine, I just wrote sine there so that you can remember that we want the reciprocal of sine. So just mind, the reciprocal of sine has got a name, and we call it, what is it? It's called cosec. Or is it sec? I'll just confirm just now. Yes, it is cosec. So have you never heard of the word cosec, Jasmine?
Well, I have.
So cosec is actually the reciprocal of sine. Does it make sense now?
Yes, sir.
Let's talk about the reciprocal of cos. What is it? Do you still remember what it is?
Is it sec? SEC?
Yes. So sec angle is the reciprocal of cos angle. So what will be the reciprocal or the ratio in terms of all of those? Meaning, explain it to me in terms of opposite, hypotenuse, adjacent, and x, y, and r. What is it?
So it's adjacent over hypotenuse, which would be hypotenuse over adjacent.
Which would be hypotenuse, yes, hypotenuse over adjacent. And then in terms of x, y, and r,
R over X.
r over x. R over x, 100%. You just get it from there and then you do the reciprocal. Let's talk about tan. What is the reciprocal of tan?
Cot.
It's called angle. Interpret it, Jasmine.
So it would be X over Y.
Mm-hmm.
For that, it would be adjacent over opposite.
100%. So adjacent over opposite. So this is how you interpret it. You always start with their names, and then from there you can represent them in terms of x or y and r. So let me see. So Jasmine, will you never forget that cosec is actually the reciprocal of sine, and then sec is for cos, and then cot. Obviously for tan is easy. You will never forget, ne? Okay, because there was a way in which this thing could be cramped. I'll give you the best way so that you will never forget these things. So, in case if you want to teach your friends, your classmates, or whoever, and they struggle in terms of remembering which reciprocal is which for which trig ratio, this is how you do it. I think it will also help you, Jasmine. Can you see? We have, you know that we've got what we call a cosec. We've got what we call sec. We've got what we call what is it? Tan. So there was a lady called LB in one of my lessons in that group. Remember, I think it was on Friday. I added you into that group where you attended that lesson. So there was a lady called LB, because normally in those groups, as other learners are attending and they are being taught different information from their groups, from their schools, we sometimes share in terms of the strategies. So just so that it can benefit others, because I might explain something of which there's another better way of cramming it. So we just share. So LB taught us this thing in class, Jasmine, and I think it's going to help you also. She says, for as long as you know there's something called sec, there's something called cosec, there's something called cot, and not tan over there. Can you look at the third letter? For this one, what is the third letter, Jasmine?
S.
What is letter number 3?
S.
Oh, okay. So it's S. So you know what she said, Jasmine? She said this S, it corresponds with the first letter of its corresponding trig ratio. So that means this S is for sine. So that means cosec and sine, those are the trig ratio and its reciprocal. What is the third letter for sec?
E.
No. Third letter.
C.
So we only concentrate on the third letter.
C, sir.
C. So that means this C is for cos. So that means cos and sec, they go hand in hand. There, what is the third letter?
T.
T. So can you see that T is for tan? Does it make sense now?
Sir.
Jasmine, are you sure? Did you understand that?
Yes, it's an easier way of remembering it.
It's the best way, Jasmine. I was very happy after realizing this because it makes it easy to explain to someone in terms of how do you notice which reciprocal is for which trig ratio. So this is how you can cram it. So Jasmine, I think for now, I've gone to where I wanted to take you to. You are lucky because in one of my previous lessons, I've already done trigonometry. So that's why I was able to present this lesson because I've got the notes already. So for some other chapters, if maybe you wanted a lesson on another chapter that I haven't prepared, it's unfortunate I wasn't going to be able to do that lesson, but we're going to just have to do a lesson that I prepared for. So that is why it helps to say on our next lesson, this is what we'll be doing. Then I prepare for that lesson so that I produce the best or good lesson. But Jasmine, up to this point, just give me a feedback in terms of my teaching style, because this is our very first lesson and I'm not yet sure if you are following or if I'm losing you. What's your
So I
feedback?
understand very well. Everything that you taught so far is very clear to me, and understand it very well.
100%, Jasmine. So now, as we continue on our next lesson, we'll be doing a special angles. For now, I'll leave it here and then I will train you on how to solve the problems that you send to me via a WhatsApp, because it's part of Trig and I notice it's something that we'll still get to, but just so that I don't keep you waiting, I'm going to guide you in terms of how you solve them. So on our next lesson, Jasmine, we'll continue to what we call special angles. Do you know or have you heard about special angles?
Is it like the angles that you solve using SOHCAHTOA?
Okay. Yes, but what are those angles? Do you know what are those angles?
I'm not sure.
Or maybe, let me say, do you not remember 30 degrees, 45 degrees, and maybe let's say 60 degrees?
No, so this is unfamiliar.
Okay, then it's fine. This is what I'm going to teach you on our next lesson. We'll be talking more about special angles, and then from there, we'll try to do some problem solving related to a trig, a triangle, and then from there we'll do expanding ratios. Let me see. From there we'll do the graphs or the functions. Then we'll be done with trigonometry. It's not that much complicated or difficult, Jasmine. You just need to be understanding all that I'm saying to you now, and then towards the end or after we have done with all that I needed to teach you, will be doing exam question papers. So that means all that we'll be focusing on is just to solve exam question papers on trigonometry. But because we are recording our lessons, Jasmine, it means just in case if you want a revision on something, we can just replay this lesson. I'll be with you. And then in case if you still have some additional questions, then I'll answer the questions in the end of the lesson, just like we did on Friday. Luckily, you guys said the lesson was clear and 100%. So, Jasmine, I've been doing these tutoring lessons for some time, and I'm at a stage where I'm able to just present a lesson from the start up until the end without having any interruption, because I know how to make it clear. I know how to make it straightforward. But in today's lesson, I wanted us to be talking to each other because I wanted to test your level of understanding. And I'm already having a feeling that we'll be having a good upcoming lessons. So, Jasmine, let me just check some of the problems that you have sent to me over there. But before I do that, if you are given 2 plus x is equals to 4, how do you solve for x there, Jasmine?
So I would take the numbers to one side so that the variable can be by itself, so that we can solve for the variable. So I'd take 2 to the other side, and it would be 4 minus 2.
100%, Jasmine. Let me try to connect to Wi-Fi and get that information that you sent to me. Jasmine, I forgot to tell you, but I just explained to your dad to say, I normally don't help at all with what is it, homework, assignments, project, and what else? So, and also homework. Mm-hmm.
So that's not a homework. It's just
Oh, it's not a
an
homework. It's
activity.
only.
It's just an activity that I that my teacher marked and I got a low mark for.
Oh,
So I wanted to improve on that
okay.
activity. So that's why I sent you my working out and stuff, because I'm not sure which one is correct and which one is right.
Okay, 100%. So, as we continue with some more of our lessons, Jasmine, I'm going to teach you on how to prove if your answer is wrong or correct, or how to correct your mistake. It's unfortunate we started with a trick, but there's somewhere I wanted us to start, of which what I'm going to do, Jasmine, I'm going to prepare that lesson, then I will play it to you, and then in the end, we will discuss that lesson. So that's where I normally start when I do my one-on-one lessons. But if you are saying x is equals to 4 minus 2, that means x is equals to 2. Do you agree?
Yes, sir.
So when you prove if your answer, Jasmine, is correct, that means you must say where you see x, when you substitute 2 there, it must give you that. So what I'm saying, Jasmine, is that when you say this 2 and you say that plus over there and you substitute whatever x value, you must get 4. So do you get 4 when you substitute?
No, sir.
What are you getting?
2.
So when I say when you substitute, Jasmine, it means you're going to punch 2 plus 2 and it must give you 4.
Oh, yes, I understand now.
Does it give you 4?
Yes, sir.
Then it
Yes.
means your answer is correct. I'm going to give you another example now. Let's say you are given negative p plus 1 and this is equals to 3. Can you solve for p there, Jasmine?
I would take the positive 1 over to the 3, which would become negative 1,
Mm-hmm.
which is equal to 2, and then negative p will be equal to 2.
Negative p is equals to 2, okay?
So then p is 2.
So p is equals to what? 2.
Yes, sir. Negative p, sorry. Negative p.
Okay. But remember, we want you to solve for p and not negative p. So what is p?
Oh, okay. P is 2.
So you're saying p is 2.
Yes. Yes, sir.
Okay. let's try to substitute it into the original formula and check if it gives us 3. So that means you're going to say negative, can you see, is that negative, into whatever your p-value is, then you say plus 1. It must give you 3 on a calculator. So can you substitute and calculate and let me know if you are getting 3?
So -2 plus 1 is equal to -1.
So what does it mean already, Jasmine, regarding your answer being 2?
That 2 is not correct.
2, it is not correct. So this is why your teacher is going to give you a wrong over there. And the reason to that, Jasmine, it's because let me just remove all of this. I'm going to show you how you solve that. So you have negative invisible 1p over there. Do you agree there's an invisible 1 there, Jasmine?
Yes, sir.
So this is plus 1, it's equals to 3. Yes, you are right. Negative invisible 1, it's equals to 3 minus that, and it's 2. But remember, Jasmine, you want to remove everything attached to a p there. So you divide by a -1. Whatever that you do on the left, you also do on the right. Why do you divide? It's because you want it to cancel. So that you just remain with p. So what is 2 divided by -1?
-2.
So it's -2. Let's now substitute. So that means it's negative into -2 plus 1. Will it give us 3 now?
Yes, sir.
So did you notice your mistake?
Yes, I did.
Okay, I will now give you the last example. From there, we'll do those trig ratios. Let's say you are given 4 minus 3y is equals to... what am I going to give you there, Jasmine? Let's see, 7. Can you solve that one?
Yes, sir.
What is it?
So you take the 4 to the other side. So it will, yes, and then we divide -3 on both sides. Which is -1.
Okay, let's now try to prove if this -1 is correct. So you are going to have 4, 3 into -1. Will it give us 7?
Yes, sir.
Okay, if it gives
Yes,
us
I does.
7, what does it mean in terms of that answer of -1?
-1 is correct.
100%. So now let's go back to the business of the day. So in today's lesson, Jasmine, I prepared you for this type of lesson where I'm actually going to be taking you through actually introduction to maths, and our next lesson was going to be solving. And then after solving, I was going to tell the stage in terms of the leveling of your understanding, because when you go to a doctor, Jasmine, and you say you've got flu or whatever the sickness you're having, they don't just give you medication. They first try to diagnose and do some checks. They check few things, and then from there, that's when they can prescribe a suitable medication to treat your sickness. So that is exactly what I was going to do. But I noticed that you wanted a trigonometry, and luckily I had it prepared. So that is why I didn't mind taking you through a trigonometry. So that's why in the beginning, just mine, I said you hijacked my lesson, but it's fine. On our next lesson, we'll see if we can do what I wanted to take you through, or just finish off trigonometry. You just choose. I also don't mind finishing off trigonometry because I've already prepared for it. So, okay, let's see, Jasmine. This is 3 sine angle. It's equals to 2,314. What are we solving there, Jasmine?
Oh, we're solving for theta.
We are solving for theta, and they said correct to 2 decimal places, isn't it? Just mine.
Yes, sir.
Okay, so how many terms do we have on the left side of the equal sign?
1,
On the right side?
1.
So if you have one term on the left and on the right, you don't transpose. Do you know what is to transpose?
I'm not sure.
So it's more like, let's say if you have 4 plus x is equals to 7. Okay, how many terms do you have on the left?
2,
Right?
1.
So if you have more than one term on any side, that's when you transpose. So to transpose is to take 4 to the other side and it changes the sign, it becomes -4. Nay.
Oh, okay, and I understand.
But if you don't have more than 2 terms or more than one term on any of the sides, you don't transpose. There's nothing to transpose there. But what do? You remove everything attached to whatever that you are calculating. So for example, if you have 2, let's say if you have 2p, it's equals to 4. You have one term, you don't transpose. But what you do, you remove everything attached to p if you are calculating for p. How do you remove this thing attached to p, Jasmine?
You would divide 2p by
Yes.
both sides.
You divide 2 both sides so that you remain with p, and then p is what you want to calculate. So there, Jasmine, how do we remove everything attached to theta, because that is what we're calculating?
You divide by 3.
Okay, so that means you divide by 3, it cancels, you remain with sine angle, it's equals to, what is that, Jasmine?
0.77.
Just that.
Yes.
Okay, 0.77. Remember, theta is what we are trying to calculate. How do we remove everything attached to theta?
You would have to you have to say sine -1 in brackets 0.77, and then you have to work that out.
So whatever that you are saying, Jasmine, you are simply saying you divide by sine on both sides so that it cancels and you just remain with angle. But a calculator does not allow a number divided by something. That is why you say theta is equals to second function. We call it second function of 0.77. Does it make sense there, Jasmine?
Yes, sir.
So do you now understand that when you are given a math problem, you just divide or remove everything attached to what you are calculating if you just have one term? Does it make sense there?
Yes, sir.
So
Understand.
this is how you're going to get an answer for that question. I'll choose another example. Maybe let's say But what is this? When you punch this thing, what is this? Does it give you that long thing number?
Yes, sir.
Okay. If it
Yeah.
does, it's fine. What is that number, Jasmine?
50,35388, and then it carries on.
35388, and then what?
5.
5, and then
That's it.
okay. So can you see? This is the value of your angle, Jasmine. That means if you want to prove if this angle is correct, what do you do based on what I've told you before with the P and X and Y?
You substitute.
Yes, you substitute. Let's substitute. So punch on a calculator 3 sine into you said it's 50,3538885. I think you said this. What are we expecting when we punch all of this, Jasmine?
Two comma 314.
Yes. Are you getting it?
Yes, sir.
Okay. Then if that is the case, Jasmine, can you see that this is correct?
Yes, sir, I do.
Okay, let's now try let's try this one. So can you see I'm going to divide by cos on both sides, then I'm going to remain with 2 cos. So that means because calculator doesn't allow, then I'll punch it like this. Does it make sense?
Yes, sir.
Then I'm going to divide by 2 on both sides so that it cancels, and then angle is equals to the whole of that. So that's how you solve it, Jasmine. I notice we are running out of time. I'll just remove all of this and quickly explain to you how you deal with those other ones. Then you'll prove if they are correct. 1.3, you've got tan angle over 3 is equals to 2,671. So I notice you know you cross multiply, isn't it? Just mine.
Yes, sir.
Does it make sense, that one of multiplying by 3?
Yes, we multiply by 3 because we have to do the opposite, and the opposite of divide is multiply.
Yes, so it's more like on this side is over 1. So it's that times that and this times that. So let's see. So 1 times tan is that. So can you see, I have to divide by tan so that I have theta. But the calculator only wants me to punch it like that. So if you punched this, you can write it as whatever decimal that you get. But because I don't have a calculator, I'll just say 3 into 2,671. Does it make sense there, Jasmine?
Yes, sir, it's much more clear now.
100%. So let's see. 1.4, you've got 1 over 3 sine of angle minus 20 there. It's equals to 0,292. How many terms on the left? How many terms on the right?
Oh, there's still 1.
1. So that means I have to remove everything attached until I get to what I'm looking for, isn't it?
Yes, sir.
So that means I'm going to divide by that. Do you agree?
Yes, sir.
On both sides. So that means you're going to divide by that. You just remain with sine of angle minus 20 degrees is equals to this thing. So do you agree, Jasmine, that, okay, what is this?
It's a term. I don't.
So say 0,292 divided by, in brackets, say 1 over 3.
Oh, that's okay. 2. That's 0,876.
So this is how you punched it. Nay, you have a calculator that has a fraction button, isn't it?
Yes, sir.
So you punched it like this, ne?
Yes, sir.
And you're getting
0,872.
Yeah.
I mean 876. Sorry.
876. Okay, 100%. So this is exactly what you're getting. Then, can you see? I want to divide by sign because I want to remove it there until I get to that. So that means I'm just going to remain with theta minus 20 because I divided by sign and it cancelled. That's why I'm saying I remain by that. Whatever that you do on the left, you do on the right. But because you can't divide by sign, it only allows you if you punch it like that. So second function, or however you call it, sine to the -1. This thing, Jasmine, is the same as a 1 over sine. So it's more like you divide it by sine. I'll explain to you when we do the laws of exponents. That's when it's going to make perfect sense. So you punch all of this, Jasmine. When you punch all of this, what are you getting? Just mine. Just mine.
Oh, yes, sir. Sorry, I was muted.
Oh, you forgot to unmute. So you were busy preaching
Sorry.
there, but you were muted.
Sorry, sir. The answer I get was 61,163.
61,163.
But there's more numbers.
Okay, let's say there's more numbers. You write them up until the last if you it's not the final answer. Ne?
Yes, sir.
Okay, how many terms do we now have on the left and on the right?
2 on the left and then 1 on the right.
You remember, if we have more than one, if possible, we can transpose. Do you remember?
Yes, sir. So you take
So
the -20 over.
100%. So that means on your calculator, you can just say whatever this plus 20. Is it going to give you what? 81,163, same thing there. Then you can take all of that, Jasmine, and put it, then say tan that over 3. No, it's not that one there, but it's this one here. You can say 1 over 3 sine into, you punch all of this, and then you say minus 20, and check if it is going to give you that. Exactly how I explained there, Jasmine. So, makes sense, ne?
Yes, sir. Thanks.
And then
Thank you.
that other one, Jasmine, question 2, I think you got it correctly. You just substitute those values there. You are not
Yes, sir.
solving there.
Yes, I understand now. Like what you
Mm.
explained now made much more sense, so I can do that one.
You can work them out, isn't it?
Yes, sir.
Okay, so there, the last one they are saying, given that AB is equals to 9 in the following triangle. Okay, let me quickly draw that one. So this is where we are still heading to, Jasmine. But I had to start where I started because that is the starting point, and this is not the starting point. Nay.
Yes, sir.
I'll just give you a clue on this one, but if you don't understand it, don't worry, we are still getting there. So they are saying, given that AB, this is AB, it's 9 in the following triangle, find the length of side CD. So this is the side CD that they want you to calculate. So do you see a right angled triangle there?
Yes, sir, I do.
Which one is it?
Triangle ABC.
Triangle ABC, yes. And also triangle ADB. Is it not a right-angled triangle?
Yes, sir. Yes, sir.
It is. So, Jasmine, is it not possible that we can maybe try find that side?
Yes, sir.
Okay. How are we going to get that side?
You gotta say DB over 9 is equal to...
Wait. Remember, Jasmine, I'm talking about from here to there. Nay, here from there to there.
So I'm not sure.
Okay. So can you see, Jasmine? Because this is not the starting point. Even if I explain, if they give you a similar problem, you won't be able to confidently tackle it because you did not start at the starting point. So that is why I won't bother Jasmine to explain to you that one, because I haven't taken you through the starting point. Does it make sense?
Yes, sir, it makes sense.
So that is why, Jasmine, for every learner who says or who sends me something to say, can you help me with this? I just ignore it with confidence, Jasmine, because I know it's a complete waste of time. You will understand better. The reason to that is because, Jasmine, I explained to you this one, but I haven't taken you through the starting point. They give you a different, similar problem. You won't answer it. So, do you now understand why I'm saying it's a waste of time?
So I understand.
So, that means I need to first take you through the beginning of this part of the problem. But for now, I see you are at an advanced stage. I'm going to guide you in terms of how you solve this one. So you will work it out and you will let me know if you get it correct. So let's check. You can find maybe this side. So that means you can use this triangle. You have a right angle there, you have 9, and then CB is what you're looking for, and then you have 35 angle there. So here, you can maybe use tan to find a BC. So it's going to be tan of 35 degrees is equals to opposite. What is opposite? Opposite is 9 over adjacent is BC. Then you calculate BC, Jasmine. Name. So you are going to have your BC as a value there. You solve, you get BC. Then from there, you can maybe, use this bigger triangle, Jasmine. You can maybe use this bigger triangle there. Of D, A, and B. To calculate BD, remember, Jasmine, can we easily find this angle there? I think we can. If we can, then we'll be having this angle there, which is going to be that angle there. Do you know how we can find that angle, Jasmine?
So, not
Okay.
sure.
So you remember the sum of interior angle is equal to 180 degrees, ne?
Yes, sir.
So that means when you add that 35 there, and when you add that 90-degree angle there, and when you add this angle of A that you don't know, the sum must give you 180 degrees. So can you see? You just solve for angle A by transposing, then you have angle A. Can you see?
Yes, I understand.
Yeah, so now you have that angle A. So you just add it with 15, then it gives you this angle over there. So that means in this triangle of A, D, and C, angle A is actually going to be equals to
55.
that 15 plus whatever that angle it is.
Yes, sir.
So what is that angle, Jasmine?
55 degrees.
Okay, let's say it's 55 degrees. So now, can you see? You still have that 9 and you want a B, a D. So you can still use, what is it? Is it still going to be tan? Yes, because you have opposite and that. So that means it's tan 55. But in this case, Jasmine, what is your opposite? Can you see it's BD and your adjacent is 9?
Yes, sir.
Then you are going to calculate what is it? BD. But remember, Jasmine, remember that BD is actually that total length.
Yes, sir.
So that means for you to just calculate that one, which is what? Which is CD. The question wants you to calculate CD. So CD is going to be equals to that total length. Do you agree? Which is BD.
Yes, sir.
Then you can subtract or minus BC. Do you agree?
Yes, sir.
So this should be the formula that you must have, which is going to help you to calculate that side of this. So Jasmine, this brings us to the end of our lesson for today. It's unfortunate it took longer than expected. So I normally do 1 hour lessons, and then from there I give you a homework to do. Or otherwise, in case if you're busy with some schoolwork, there's no need to give you a homework. So in case if I give you a homework, there's no deadline. Even if you give me in 2030, it's fine. I'll still mark it. So
Yes, sir.
are you happy, Jasmine?
Yes, sir. I understand well.
Yeah. So that means you will get ready for our next lesson.
Is our next lesson going to be trigonometry?
You can tell me. We have 2 options, Jasmine. We can start with the lesson that you hijacked, or we can continue with trigonometry until we finish it off. But one thing for sure, as soon as we finish it off, then I'm going to take you through the program. So I don't follow the program at school, Jasmine, because it is a program designed for you at school. But in our case, I'm preparing you for exams. So I know what you must know before you can know which chapter. So sometimes you might be doing things in reverse. For example, we can't do functions before we have done what is it, the solve for x and the laws of exponents. We can't do what is it, the trigonometry functions without having done the basics that we have done today. So that's what I'm trying to say. Sometimes you might say, can we do functions? But if you haven't done those other lessons, we won't do functions, because you will understand, but you won't have a better understanding, because I haven't taken you through where I wanted to take you through. So it's more like you haven't crawled, you haven't walked, but you say, can we run, or can you teach me how to run? Does it make sense?
Yes, sir. It makes sense.
So you tell me, Jasmine, next lesson next weekend, trigonometry or the hijacked lesson? Any is fine, whichever one you prefer.
So I prefer trigonometry because, like, that's what I'm doing currently, and I
Yeah,
would like to understand it better.
yeah. Okay, no, then it's fine. You also understand it better when your teacher teach in class, so it's fine. Jasmine, this is the end of our lesson for today. I hope you enjoyed as much as I did. As soon as we're done, I'm going to send you this lesson via inbox. Just send me an inbox reminding me to send you this lesson. Then you will catch it up at a later stage. Nay.
Yes, sir. Thank you so much.
Okay. Cheers. Bye.
Bye.